In this video, we're going to look more into resistors. As we saw with capacitors, we can add multiple at one time into one circuit. If we want to add, say, 2, 3, 4 resistors in once, we ask ourselves one question: how are they added? Now, there are multiple ways, two ways to add multiple resistors in a circuit. The two ways are in series and in parallel. If we add resistors in series, placing one after another, as you can see, we start with one here, followed by another. So this would be a circuit element, and our circuit may be considered the rest around it. Now, to find the total resistance of the circuit, if we want to figure out what is the two resistors together, what kind of resistor do they look like, we can see that the total resistance is nothing more than R1 plus R2, and we can continue R3, R4. So if they line up in a line, we add them one after another after another. Now, if we actually want to understand why this is happening, we remember that the same current flows through this whole thing. Any of the charge that comes in eventually comes out. So the current in this section is constant. So if we use Ohm's law, we can see that the voltage drop from point A to point to the star is given by the current. We don't know what it is, but we know it's given by the current times the resistance 1. V equals IR. Same thing for the next one. If we go from this star to VB, the voltage drop is given by VB minus V star. And we can see that it's R2 times the same current. Now, if we add these two components together mathematically, we'll obtain VB minus VA is equal to I times the sum R1 plus R2. We notice that the V stars will cancel out when we add, and everything else adds together. This means that the change of voltage from VA to VB is equal to the total current that we started with times the total resistance, which means that the total resistance has to be equal to R1 plus R2. And this is just what we stated above up here. Now, if we actually look into how to add resistors in parallel, it looks something like this. We start at one side of the circuit, we split, put one resistor in, combine back up, and on the other side, we come in after the split, and then eventually come back up again. And what we'll find is that we can't simply just add R1 and R2. What we have to do is, the way we add these, to figure out the equivalent resistance, or the resistance of this whole thing together, we have to add 1 over R1 plus 1 over R2 plus any other resistors in parallel will equal 1 over the equivalent resistance, or 1 over R total. And again, if we want to see why this is happening, we notice that we start with VA here. We have constant voltage up to this point. It's all VA. After the resistances, there's a drop in voltage, and we know that we have to have VB on this side. The other thing we notice is that the current flowing in will split and then join back up. So at the split, the current flowing in will split partially to I1 and partially into I2 by Kirchhoff's first law, which is the Junction Rule. So if we were to look at what's happening, look at the voltage coming in. The voltage drop from here to here is given by Ohm's law. It's I1 times R1, V equals IR. Same thing for the other one. If we start with I2 times R2 has to be equal to the same voltage drop, VB minus VA. And as we said, with Kirchhoff's first law, the Junction Rule, the total current is equal to I1 plus I2. So I is equal to delta VAB over R1. I2 is equal to VAB over R2. I is equal to I1 plus I2. We combine the two equations, and we see that it's given by R1 over R1 over R1 plus 1 over R2. Which means that if we look at the current going in is equal to the voltage divided by the total resistance, and we can see that, again, 1 over R1 plus 1 over R2 is equal to 1 over R total, or our equivalent resistance.